So Assalamualaikum and good morning. So right now, we present about our project. It's the title project is Traveling Salesman Problem (TSP) and Algorithm Exploration. So my name is Farhan.
Hi, my name is Amanina Husna.
Hi, my name is Natasha.
My name is Fatehah.
Hello, my name is Zul Azri.
So the introduction about this project is the traveling salesman topic. TSP is a fundamental problem in optimization, mathematics, and computer science. TSP aims to determine the quickest path for a salesman to travel over a series of cities, making precisely one stop at each location and then heading back to the beginning point. So about greedy algorithm. A greedy algorithm is a problem-solving technique that builds a solution incrementally by making the most optimal choice at each step, based on the current situation without considering the broader consequences of the decision. It aims to achieve a global optimum by following a sequence of locally optimal choices.
So this my part is divide and conquer. So the concept divide and conquer is a problem-solving approach to break a problem into the small sub-problem, solve them independently, and combine their solution to solve the original problem. Sorry.
Next is dynamic programming. Concept dynamic programming divide complicated problem into smaller, more manageable sub-problems, solve sub-problem, and solve the solution for later use. Effectiveness frequently result in highest memory utilization, particularly when dealing with issue involving higher input order or a large number.
Hello everyone, I will talk about the backtracking. So in this slide, you can see the concept of backtracking. Backtracking is a methodical technique to problem solving. You attempt to fix an issue by trying many solutions until ultimately works. If one part fails, you backtrack and try another. It's perfect for testing various possibilities, such as solving maze or puzzle until you find the solution or run out of all options.
Next, sorting. The insertion sort algorithm sort a list of value by repeatedly inserting a new element into a sort sublist until the whole list is sorted. Therefore, the complexity of the insertion sort algorithm is O(n) power by 2. Hence, the selection and insertion sort are of the same time complexity. When processing for TSP, by pre-sorting the rows of the distance matrix, the algorithm can quickly access the smallest value in each row, representing the shortest distance to an unvisited city. Next, searching. The concept is binary search tree store data in nodes that are linked in a tree. For randomly inserted data, search time is O log n. Binary search tree in a data structure used to arrange and store data in a sorted manner. In a binary search tree, every node can have a maximum of 2 children, a left child and right child. The left child values are smaller than those of the parent nodes, while the right child values are larger.
For public hidden method greedy TSP, declare n as distance length, declare visited as array of boolean with size, declare current city as integer 0, declare total distance as integer 0, and declare current city as integer true, and declare path as string builder equal to new string builder with a. For I from 0 to distance length, declare next city as -1 and declare shortest distance as integer max value. For j from 0 to distance length, if not visited, and distance current city, minimum shortest distance. Shortest distance equal to distance current city, and nearest city will equal with j. Visited nearest city will equal to true, and total distance with shortest distance current city will equal to near city, and path append will same with city names and current city. So after that, we return to the starting city and end of the method.
For the dynamic programming algorithm, first public hidden method dynamic programming TSP. declare n as integer, declare visited all as integer, declare memo as 2D array of integer with size, declare path as 2D array of string with size, and helper function to compute the cost, declare cost as integer, declare dynamic programming TSP, helper, return total cost and path from starting city, return minimal distance cost, and method. Next, dynamic programming TSP helper algorithm. Private heading method dynamic programming TSP helper. Check if all city have been visited. Check if the result is already computed. If memo was must, return memo. And if declare as integer equal max value, look through all cities to find the minimum cost path for city from 0 to distant length. Check if the city has not been visited yet. If must and when left shift city. Calculate use answer recursively. Declare use answer as integer. Dynamic programming TSP helper. Update the minimum answer. Update the path if a new minimum is found. And store the compute answer is mobilization table and return it. And method. Next algorithm.
Hello everyone, so we're back to the backtracking TSP. So as we know, backtracking, we try to every possible route, but really visiting all cities. After visiting all the cities, is calculate to the total cost and keep off the minimum cost route. So as you can see in this code, so I will start the new code by the public static string backtracking TSP. So I will put the boolean, declare the boolean for the visited. So I declare the visited 0 for true to start the city 1, city 0. So I declare the string builder part. So this one with string builder to put the name as a city name as a 0. So I continue by the int cost. So int cost is mean the TSP backtracking for the start from 0, this visited, this name 1, 0 and path. So and the last for this code, the return minimal distance cost will put the string plus cost at the just now we put and continue with pass and pass to string. So for the second code is for the int. So I put the private static int TSP backtracking. So this will put the int post for just now. We put all of the data code in this coding. So I declare if to count and int answer for attract all the part in this int. So the next for declare, so int I equals 0, and you can see in this for you can see the if I declare if here to visit the true or false for this backtracking. So I think that's all for me.
So as my part is the divide and conquer TSP. So as you can see, using the main method for divide and conquer TSP. So I create a visitor array to track either each city to be visited. So starting from city 0 and we mark the visited. So after that, I using a string builder to track the part and starting with the city 0. Then I call the helper function. Is it divide and conquer helper to revise find the shorter routed. So as you can see, so I put the coding is a public string, static string divide TSP. So I put 2 boolean visited. Then you can see the return minimal distance cost and part. So the second is a private static int divide and conquer helper. So at here I put 2. So how to can the words to coding words? So I put the answer in and answer equal integer dot match the underscore value. So as you can see, I call 2 for int I equal 0. So I put 2 if we visited and dispose. So yeah, from me.
Next, insertion sort algorithm. Firstly, public hidden method insertion sort array. Initialize output as array from index from 1 to array length minus 1. Do set key to array. Set j to I minus 1. Shift element array from 0 until 1 minus 1 that are greater than key to 1 position ahead, while j more than equal to 0 and array j more than key. Do set array j plus 1 to array. Decrement j by 1 and while. set array j plus 1 to key, append current array state to output. Output must have index and array. Append sorted array and return output. Next, binary search algorithm. By public hidden method, binary search that include array and target. Initialize output as searching for target and set left to 0, set right to array length minus by 1, while left must less than to the right, do set mid to left plus right minus left divide by 2. Log the middle element being checked, append checking middle index that equal to with the value and array. If array mid equal to target, then append target found at index and return output. And if array mid less than target, then set left to mid plus 1, and else set right to mid minus 1, and if and while, and append target not found to output and return output, and methods.
Okay, for the conclusion, as we know, for conclusion for TSP, we use the algorithm, greedy algorithm, dynamic programming algorithm, backtracking algorithm, and divide and conquer algorithm. So each with advantage and disadvantage. The greedy technique is the faster but frequently generate poor result, whereas DP is mean the dynamic programming provide the best balance of accuracy and speed, making it ideal for small to medium-sized dataset. Backtracking provide the greatest result, but is slow due to its exponential complexity. Divide and conquer provide a symmetric technique. However, it performs worse than DP in this scenario. The code also include basic algorithm like insertion sort and binary search. The experiment highlight requirement of choosing algorithm depending on problem size, limitation, and a trade-off between speed and accuracy. Alright.